the mid-segment of a trapezoid. Let's go back and review mid-segments of triangles. See if you remember this. If you were dealing with a triangle and we took and found the midpoint for one side, which is about right there, and we found the midpoint for the other side, which is about right there, and we connected those two midpoints, the line segment that was formed was called the mid-segment. Now here's the thing, anytime you draw a mid-segment, we had a theorem that stated that this mid-segment would always be parallel to the base of that triangle. It would always be parallel to that third side. And not only was it parallel, but there was something else that was true about it. I don't know if you remember, but anytime you drew that mid-segment, you actually had similar triangles. Remember that? The little triangle and the whole triangle are going to be similar to each other. And you've got a scale factor here. Since this was the midpoint, right? Yeah, there's a 1 to 2 ratio. If this is 2, then this is 2. So the whole thing will be 4. So it would be a 2 to 4 ratio. If this is 3, this is 3. So it would be 3 to 6. Or a reduced ratio, it's always a 1 to 2. The top part here will always be half of the whole thing. So what's true about a mid-segment's length? It's always what of the base? It's always parallel, but not only is it parallel, but it's always, think about that ratio. What if this down here is 10? What's this going to be? 5. A mid-segment is always half. In a triangle, the mid-segment was always half of that third side. Well, what about the mid-segment of a trapezoid? I bet if you think real hard, you could figure it out. Let me say that the top here is 6 and the bottom's 10. You have two bases of a trapezoid. Once again, a mid-segment connects the midpoints of the sides. If the top is 6 and the bottom's 10, well, does everybody understand that that mid-segment is going to be somewhere in between the two? What's it going to be? It's going to be 8. You already know this. Like I say, guys, a lot of times in geometry, if you think real hard, a lot of this stuff might turn out to be just common sense. A mid-segment, and that's where it leads us to our next one. The mid-segment of a trapezoid is always parallel to the base, same as a triangle. And not only is it parallel to the base, but its measure is 1/2 of the sum of the lengths of the bases. And an easier way of saying that is the average of the bases. To find the length of a mid-segment of trapezoid, you simply average the top base and the bottom base, and you've got it. That's what we did on the last one. 6 and 10. Add the 2, divide by 2, you get 16 divided by 2, which is 8. Work against problems. And we're going to start out with a difficult one, because we've worked basic on that last one. You add the 2, and you divide by 2. It says in this figure, LH is a mid-segment. What is the value of X? First off, let's use common sense. Guys, is X going to be bigger or smaller than 15? Smaller. Should be smaller. Okay. So how in the world are we going to find X? Let me show you the hard way of doing it. I know that when I average the two bases, I add them and I divide them by 2. And I know when I average those two bases, it's going to give me the length of the mid-segment. You could set up an algebraic equation to solve this. Okay, that's one way of doing it. What do we do first? What do we get rid of first? What do we move over first? Yeah, the whole thing is being divided by 2. So how do we move it over? Yeah. So that gives me X plus 18.2 equals 30. So you get 11.8. Subtract 18.2, you get 11.8. So the top base is 11.8. Do you remember the shortcut I showed you for well, it was a midpoint problem. Let's say you're given this. You're given a midpoint, which is 3, 7. You're given an endpoint, which was 1, 2. And you're asked to find the other endpoint. Do you remember the shortcut I showed you for that? 1 to 3 to 5. It's an arithmetic sequence. 1 to 3 to 5. 2 to 7 to 12. You're adding 5 each time. On the first one, you were adding 2 each time. So the other endpoint would be 5, 12. Can I do the same thing here? Yeah. Okay. Anytime you're dealing with averages, 18.2. To go from 18.2 to 15, you subtracted 3.2. So can I just do that again? And you get 11.8. Anytime you're given a mid-segment, which is very similar to a midpoint, right? Anytime you're given a mid-segment and you're asked for that other base, simply follow an arithmetic sequence there, and you can do it a whole lot easier. Trapezoid ABCD is shown at the right. If FG is parallel to AD, okay, let's go here. FG is parallel to AB. What are the coordinates of point G? That's tough, right? I believe if you look back, first off, is this the midpoint? 0, 8, 9, 8, 18, 8. Isn't the distance from here to here 9? 0 to 9, and 9 to 18. The distance there is 9. So if it's got a midpoint here, okay, this is congruent to this, and it's parallel to the base. Would this be a mid-segment? Sure. So wouldn't that equal that? So the easiest way to find the coordinate of G, would G not be the midpoint between 1, 4 and 20, 0? And can we find that in our head? Can we do that pretty easy? Find midpoints, add the x's, divide by 2, add the y's, divide by 2. I want to find out what point is directly in the middle right here. Add your x's. Do this for me, Alex. Add your x's. You got 1 and 20. And tell me what's in the middle. Good. 10.5. Add your x's, divide by 2. Add your y's, divide by 2. What do you get? So that would be 10.52. And that is a mid-segment. It's parallel to the base. Anytime you got that line in the middle, it's parallel to the base. It's hitting the midpoint on this side. It's also going to hit that midpoint on the other side. Next problem. Well, actually, one kites. Let's talk about kites. And this is our last quadrilateral. After kites, we're completely finished with quadrilaterals until the next time one pops up in problem. A kite is a quadrilateral, and we already know this. A kite is a quadrilateral with exactly 2 pairs of consecutive, meaning one right next to the other, consecutive congruent sides. PS and SR are congruent. They're consecutive. RQ and PQ are consecutive congruent. And they have no parallel sides. The opposite sides of a kite are not congruent, and the opposite sides are not parallel either. SR and PQ, no, those are not parallel or congruent. Here's your kite properties. Write them down. If a quadrilateral is a kite, and what I would do is I'd just say, okay, now we're talking about kite. Here's my properties. If a quadrilateral is a kite, then diagonals are perpendicular. So it has perpendicular diagonals. And not only does it have perpendicular diagonals, but it also, if a quadrilateral is a kite, then one pair of opposite sides or opposite angles are congruent. One pair of opposite congruent angles. And so while you're writing that down, let's go back. The first property up here, it has perpendicular diagonals. Now just keep in mind, some of these properties are not just exclusively one shape's properties. We had another shape that had this exact same property. So remember what it was? What other shape had perpendicular diagonals? A rhombus. Okay. Rhombi also have diagonals that are perpendicular. One pair of opposite congruent angles. Do we have any other shape that only had one pair of opposite congruent angles? Because parallelograms, everything else that we've done have been parallelograms, right? And what's true about the opposite angles of parallelogram? They're opposite angles. They're equal. And not just one set, but both sets. So this is the only shape that we've ever seen that has one pair. So how are you going to tell which sets of angles are congruent? Because it says it only has one set of opposite congruent angles. Are these angles going to be congruent? No. Draw this diagonal. You see the symmetry? Now, are those two triangles going to be congruent? Yes. It has a line of symmetry. You talked about line of symmetries ever since you were in kindergarten. It has a line of symmetry. The left side and the right side are going to be the same. Now, how do we know that we've got two congruent triangles there? Ignore the angle because I'm fixing to try to prove that those angles are congruent. How do I know this and this is congruent? By definition of a kite, consecutive sides are congruent, right? Is this side equal to itself? Why are those two triangles congruent? Side, side, side. All three sides are congruent to all three sides. Since they are congruent, then by CP/CTC, those angles would also have to be congruent. Okay? Look for your lines of symmetry. So if this is a kite, find the measure of angle GFJ. GFJ. We'll look for this angle. Do you see that line of symmetry? Do you see that you could cut it? Will this angle also equal this angle? Sure. And Jagger, remind me, since this shape has four sides, what's those four angles going to add up to? Careful, four sides. That's triangle, three sides. Four sides will be 360. So we've already got 72 and 128. If you add those together, you get 200. Take that away from your 360, you're left with 160. But you have two angles that have to add up to that 160. But they're the same. Anybody, how much are they a piece? Good. 80 here, 80 here. Any questions? Again, on all these problems, keep in mind that symmetry. You can see this is a line of symmetry. This is not a line of symmetry. Okay? If WXYZ is a kite, find ZY. Now, how in the world are we going to do that? We're looking for the distance from Z to Y. Any ideas? Look back in your notes that we just wrote down. Matt, in a kite, the diagonals are what? Perpendicular. So this is right angle, right? Everybody knows perpendicular lines intersect to form four right angles. So how in the world are we going to find the distance from Z to Y? As we have for the past, seems like 3 months, we're going to use Pythagorean theorem. I would learn that. I really would. By the Pythagorean theorem, a squared plus b squared is equal to your hypotenuse squared, which is what you're looking for. 64 plus 576, go check me on that, equals x squared. Thank you. This is 640. Thank you very much. Equals x squared. And that, boy, isn't that tempting to say that the answer is 80. But it's not, because 80 times 80 would be 6,400, not 640. So we're looking at an x value that is the square root of 640. Tell you what, let's do this. For extra practice, let's go back and let's talk about how to reduce that. If I don't want a decimal answer, I want an exact answer, because this one would be pretty easy to reduce. Find two things that multiply to give you 640. Does anybody know an obvious one that we could use? Not 80, but how about 64? Square root of 64 times the square root of 10. So that'd be what? We can mark out square root of 64, don't we? That's 8 root 10. That's the exact answer. Or for those of you that typed in, square root of 64 is about what? 25 point what? Just give me one decimal. That's good. 25.3 rounded. Now let's check our first answer. Somebody type in square root of 10 times 8. Okay, 25.3. Same thing. Exact answer, approximate answer. Okay, moving on. Diagonals are perpendicular, don't forget it. If the measure of angle bad, there we go. If the measure of angle bad is 38, BAD, the whole thing is 38. The measure of BCD, the whole thing, is 50. Find the measure of angle ADC. Is this not the same thing we did a while ago? Yeah. Yeah, this is a duplicate problem. There's more information given here than we don't have to know. Well, that's a kite. That's what this tells us. If this is 38 and this whole thing is 50, you add those together, you give 88. All four angles have to add up to 360. We subtract that off, and we're left with 272. So each of these angles, again, a kite will have one set of congruent angles. And if you drew this line of symmetry, you can see this triangle and this triangle are the same. These two angles are going to be the same by CPCTC. So that'd be 136 degrees and 136 degrees. So the measure of angle ADC is 136 degrees. Question. I don't think, double check, I don't think we did. We didn't write this down as a property, but diagonal AC. Will diagonal AC bisect this angle right here? Yes, it will. How do we know that? Because these two triangles that I keep referring to, these two triangles are congruent. So would this angle and this angle not be congruent? Yes. So therefore, and same thing on this end, this angle and this angle would be congruent. So therefore, one diagonal will bisect the angles. Will the other one? Is this angle and this angle congruent? Not necessarily. Because you don't have congruence here. Now, if they were congruent, would it be a rhombus? Yes. Next one, BT is 5. And I think this is a duplicate problem as well. BT is 5. That's the distance from here to here. And TC is 8. And we're looking for the measure of CD, which is on the other side. Now, one thing I noticed that CD is going to be the exact same length as BC, so let's just look for BC. That would be a Pythagorean theorem problem. A squared plus B squared equals C squared. So you get 91? 89, wow, I'm way off. Root 89, that won't reduce. You could try it if you wanted to, but that's about 9.4. There's your answers. And again, that's a duplicate problem. We've already worked them like that. Okay, we're done with kites. So let's go to shapes that have more than 4 sides. So we've spent the last few days working on any type of 4-sided shape. We spent the 3 chapters before that, 3 or 4 chapters before that, talking about triangles. So here we go. Check, check, right? We've dealt with 3-sided shapes. We've dealt with 4-sided shapes, which are quadrilaterals, and now let's deal with the rest of them. If you don't know these, write them down. Any shape that has 5 sides is a pentagon, 6 sides hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 12 dodecagon. Because look, that was 10, right? We'll add dose more to it. Dodecagon is 12. What about 11? What about 13, 14, 15? Anything that's not listed, we call an entagon. If it has 11 sides, that is an 11agon. If it has 13 sides, that is a 13agon. If it has 15 sides, that's a 15agon. If it has 100 sides, that's a 100agon. Okay? Anything that doesn't have these listed sides here, we just refer to as a whatever-agon. Okay. So again, now we're talking about polygons. A polygon, which triangles and quadrilaterals are polygons. A polygon is a plane figure that meets the following conditions, and you see one over here. It is formed by 3 or more segments called sides. Notice it says segments, line segments, not curves. No curves here. Such that no 2 sides with a common endpoint are collinear. That's not really important. Just make sure that you know all the sides are lines. Line segments. Each side intersects exactly 2 other sides, one at each endpoint, and each of these endpoints is called a vertex. So in this case, not only does it have 5 sides, but it has 5, well, they're actually plural vertices. You have a vertex at each intersection, and those vertexes, plural, would be vertices. The correct name, you can name a polygon by listing its vertices consecutively. For instance, PQRST, or you could say QPTSR are two correct names for the polygon above. You just list all the vertices. Same way you do with triangles. Okay, same thing you do with quadrilaterals. You just list their corners in order, and it doesn't have to be alphabetical order. You have two different types of polygons, and I don't like the way that they describe this. You have either concave or convex polygons. Here's how I remember this. This is a convex, and this is a concave. You know why? Because one side is caved in. That's how I remember it. Looks like it's been hit with a ball bat, right? Anytime you have a concave polygon, you've got a caved in side. And you see that here. There's a caved in corner of it. So you have convex versus concave. Make sure that you know the difference between those two. Convex versus concave. Okay, the angles of a quadrilateral, or excuse me, the angles of a polygon. We've already dealt with, and let me scroll down. I want to do this one on my own. We've already dealt with triangles. We know that in a triangle, the three angles always add up to 180 degrees. We dealt with four-sided shapes, quadrilaterals, and we knew that they always add up to 360. Well, let's talk about, I think we might have them, but let's talk about why. The three angles in a triangle add up to 180. Well, isn't a quadrilateral just two triangles? So you got 180 and 180, that always adds up to 360. If you have five sides, Superman. If you have five sides, pick a corner and just start drawing diagonals. If you have five sides, don't you have three triangles? 180, 180, 180 would add up to 540. If you have six sides, pick a corner, start drawing triangles. If you have six sides, I believe you count four triangles. Four 180s would be 720. And let's do one more. What if you had, what was that, six? What if you had seven sides? 1, 2, 3, 4, 5, 6, 7. Pick a corner, start drawing diagonals. Seven sides is how many triangles? It's five, right? And five 180s, that's going to be 900. And hopefully you see a pattern here. Okay, you had a triangle. If it had four sides, it had two triangles. If it had five sides, it had three triangles. If it has six sides, it had four triangles. If it had seven sides, it had five triangles. What if it has 100 sides? How many triangles will it have? 98. And each of those triangles will have 180 degrees worth of angles. So look back, that's what they're saying up here. The sum of the angle measures of a polygon is the sum of the angle measures of the triangles formed by drawing possible diagonals from one vertex. That's what I just did. Quadrilateral, two triangles, five sides, three triangles, six sides, four triangles. And then you see that pattern. Look at the little chart they did here. Number of sides, number of triangles. If it has n sides, whether it be 100, 1,000, whatever, it will always contain two less triangles. So therefore, you have now this formula. N minus 2 times 180. You don't have to memorize the formula if you just know where the formula comes from. If you had 100 sides, I want you to start thinking, well, if it's 100 sides, if I drew diagonals, that would form 98 triangles. And I'm going to take that 98, I'm going to multiply it by 180 degrees because each of those triangles will contain 180 degrees. So 98 times 180, and you get a big number, right? 17,600, right? So you get a really huge number there. So here we go. There's your formula. The sum of the, and like I said, you don't have to write it down. If you just know why. The sum of the interior angles, all these angles are always going to add up to n minus 2 times 180 degrees, to where n is the number of sides. And here you see an example of a five-sided. 5 minus 2 is 3 times 180, or 540. Find the sum of the measures of the interior angles of a convex heptagon. Well, first off, I need to know what they're going to add up to. How am I going to do that? How many sides does a heptagon have? 7. So what I'm going to do, since it has 7 sides, and I know we can do this in our head, but watch. It has 7 sides. Well, how many triangles will it have? How do I find that out? Minus 2. So it's going to have 5 sides. Or excuse me, 5 triangles. Each of those triangles are going to be worth 180 degrees. So that's a total of 900 degrees. So all these angles have to add up to 900 degrees. We good there? So let's see what they add up to. I've got 145 plus, watch me as I type this in to make sure I don't miss any, plus 87 plus 134 plus 136 plus 130 plus 128 plus 145. So am I done? Delete. And they do add up to 900. Just showing you, just checking it. So find the sum of the measures of the interior angles of the convex heptagon. And notice there it says convex. Those do add up to 900. Okay, we can use the formula. Most of the time they're going to give us a missing one like here. Find the measure of each interior of the quadrilateral ABCD. Is it? You tell me. What do y'all think? Is this, the question was, is this a trapezoid? Because if it is a trapezoid, there might be an easier way of doing it. Is it a trapezoid? Trapezoids have one set of parallel lines. Yes, good job. Why are they parallel? Because these are the same, right? No. Because these are supplementary. Same side interior angle. Since those are supplementary, this is a trapezoid. So what will these add up to? And that's another way you could work it. Since we're dealing with polygons now, let's do it the hard way. Since you have a four-sided shape, we already knew this. All four of these sides, or all four of these angles, are going to add up to 360. So you have x plus 3x plus 180. I just added those two together. Equals 360. Subtract the 180 and put the x's together. 4x is 180. Wasn't that what we would have got if we had just used that? Yeah, a whole lot easier. Divide by 4x, you get, or divide by 4, you get x is 45. So this is a 45-degree angle, and this is a 135-degree angle. That's too easy. Let's work harder. 5 sides. Matt, carry me through the process. Since it has 5 sides, how am I going to find out how many triangles it'll have? Minus 2. And if it has 5 sides, that means it's going to have 3 triangles. And I'm going to take those 3 triangles, and each of them are worth 180 degrees. So somebody tell me how many total? 5, 40. So all of these angles have to add up to 540 since there's 5 of them. So here we go. 2x plus 3x plus 14 plus 3x plus 14 plus 2x plus 142 equals 540. There's your equation. We've been there, done that hundreds of times, right? How many x's? Help me out with this, Colton. How many x's do I have? 1, 2, 3, 4. Is it 10? So 10x. Let's go ahead and let's save ourselves some time, guys. Combine 14, 14, and 142. Somebody for me. 170. So we're going to move 170 to the other side. How do you move 170 to the other side? You subtract it, and you get 370. Don't calculate. Don't type this in your calculator. Divide by 10. What is x? 37. Thank you. Move your decimal one place to the left. So x is 37, and we can plug this back in. Of course, we're going to. We can plug it back in to find out actually what the angle measures are. If x is 37, 3 37s, that's 111 plus 14 is 125. That's the same thing. 2x would be 74 and 74. And you can check that to see. You see any symmetry there? Sure. If there were a such thing, there's not. But if there was a such thing as an isosceles pentagon, that would be it. Because you could draw a line straight down the middle. a line of symmetry because those two angles are the same, those two angles are the same, and that line would actually split that other one too, wouldn't it? Be 71 degrees apiece. Find the measures of each interior angle of an 11-agon that appears on the face of the Susan B. Anthony and $1 coin. If anybody's ever seen a Susan B. Anthony coin, bet you didn't know it, but it is an 11-agon. Okay. Did you really know that? I give you that. So an 11-agon, we want to know what all the angles would add up to. Find the measure, but a little bit different here. It says each interior angle. It is a regular polygon, and we need to discuss that. I don't think we talked about it a while ago. Regular. What does it mean for a polygon to be regular? Does anybody know that?
All the sides are the same.
All sides are the same. And since all the sides are the same, what else is going to be true? And angles. Everything are going to be the same. All sides are the same, all angles are the same, it is regular. So find the measure of each interior angle of a regular 11-agon that appears. Okay, since it has 11 sides, how many triangles does it have? Good. We're going to subtract 2. It's going to have 9 triangles, and each of those triangles contain 180 degrees. 9 times 180, I believe, is 1,620 total degrees, right? That's not what it asks us, right? They're all going to add up to 1,620, but how many of them are there? Because we're wanting to know what is the measure of each interior angle. I can't draw it, but you've got an 11-agon. There's 11 angles. They all add up to 1,620. How do you find out how big each of them are? You just divide it by 11 because they're all the same. 1,620 divided by 11. Has anybody got that typed in yet? It is a decimal. Here you go. 1620. I got you right here. 1620 divided by 11. 147.27. So about 147.27 degrees. That's how big each angle would be. Each would be an obtuse angle. We're getting there, guys. Certain company makes hot tubs in a variety of different shapes. Find the measure of each interior angle. Again, look, it says each. Find the measure of each interior angle of a nonagon model. Hunter, how many sides does a nonagon have? There's 9 sides. If you're in England, if somebody says something, there's 9 of something. And that's 9, right? So a nonagon has 9 sides. If you want to call it a nonagon, that's fine. Because think about 11-agon, 12-agon, 9-agon, right? Same thing. So a nonagon has 9 sides, so it would have 9 minus 2 triangles. Each of those triangles contain 180 degrees, so that'd be 7 180s, which is 1,260 degrees. That's total degrees. But since there are 9 angles, and we want to know what each of those angles are equal to, Dylan, B, how do we find out how big each angle is? 1,260 total degrees. There are 9 angles. We will know what each are equal to, so you, divide by 9. Has anybody got that divided?
140.
Is it exact?
Yeah.
So exactly 140 degrees apiece. All 9 angles will equal 140 degrees. We good?
Mm-hmm.
That makes sense. We're getting some cool stuff in a second. We're nearly finished. That's the reason I'm still going. The measure of an interior angle, well, that's backwards. The measure of an interior angle is 135. How many sides does it have? That's tough. Let me show you a new formula. Now this one you might want to write down. Each interior angle. Okay. I don't know if you noticed the process, but here's what we were doing each time. We took the number of sides, and in this case we don't know how many sides it has. We took the number of sides, and carry me through the process, Dylan C. If it had 10 sides, how many triangles? How do we find out how many triangles that was? We took the number of sides and subtracted what? 2. Subtracted 2. And since now we're dealing with triangles, we'd multiply it by what to find how many total degrees? Each triangle would have 180. So does everybody understand? That's the formula for telling us what all the angles add up to. Well, how many angles are there? If there's n sides, how many angles are there? So if I divide this, isn't that what we did on those last problems? I took this, which is the total amount of degrees, and I divided it by n, and that told me how big each angle was in this problem. So this is the formula I said you might want to write down. This formula is the process at which, and you know that already, that's the process at which you found each interior angle. You'd find the total degrees, and then you divide it by the number of angles. In this problem, each interior angle is equal to 135. We're going to solve that equation. See that? Because we don't know how many sides it has. We want to find out how many sides are in this polygon. So that's a pretty tough looking equation, isn't it? How do I get rid of divided by n? Multiply by n. Doesn't that make it a whole lot easier? N minus 2 times 180 equals 135n. You could. Yeah, if you're given each individual angle, solve this equation. Oh, like this? Yeah, you could. Distributive property, and if you wanted to, even in your formula, if you want to go ahead and distribute that, it might save you a step. 180 times each of these, 180n minus 360 equals 135n. So that's a pretty easy equation. I'm going to pull a double switch here. I'm going to move all my n's to the left side. At the same time, I'm moving this 360 to the right side. Wouldn't that save a step? Help me out with that, Briley. Moving 135 n's to the left. We got to subtract them off. How many n's am I left with?
45.
Good. And that's going to equal, since this is minus 360, I'm just going ahead and moving it to the other side, equals positive 360. Somebody divide by 45. How many n's do I have? 8. This is an H-sided shape. In a second, there's going to be a much easier way to solve this. You hate it when I do that. So if something has 135, each interior angle is equal to 135 degrees, that means it has 8 total sides, 8 total angles. Here's another one. The measure of an interior angle of a regular polygon is 144. Find the number of sides. I'm going to fly through this one. Same type problem. To find each interior angle, here's your formula. You're taking n minus 2, and you're multiplying it by 180. Can I put that up front? Is it the same thing? Yeah, true. Now I'm going to divide it by n to show me what each is equal to. In this case, each angle is equal to 144. First step, I move my n that's on bottom to the other side. And why not go ahead and distribute this at the same time? So you're going to have 180n minus 360 equals n moves to the other side and gives you 144n. Move all your n's to the left, move your 360 to the right. Carly, move these n's to the left for me. Subtract them off. Tell me how many n's I now have. Good. So now 36n is equal to what, Carly? So n must be 36 times what is 360? So n is 10, because it rhymes. N is 10. Now how could I check that? 10 minus 2, multiply by 180, divide by 10, and you should get 144. Now could I use trial and error? Because I haven't seen many 2.5 sided shapes or 3.7 sided shapes. Is your answer going to be a whole number? Yeah. So if I wanted to, could I say, well, maybe it has 9, and do 9 minus 2, multiply by 180, divide by 9, and see if I get 144. Didn't work. It's too low. Go to 10. Go to 11. Go to 12. Could you use trial and error? Yeah. Is that the easiest way? No. Here's where we're going to deal with the easiest way. Let's try a little. Let's try a little project here. Draw a shape on your paper. I don't care if it has 4 sides, 5 sides, 6 sides. Let's not try to do 100 sides or anything like that. That's get a little crazy. I'm going to do a 5-sided shape. And what I want you to do, it doesn't have to be accurate as far as measurements. I know if I have a 5-sided shape that the angles have to add up to 540. I think that's right. Just make up 5 angles that add up to 140 or 540. Excuse me. Like I'm going to say that this one's about 90. This one's about 100 and let's just do 100. This one is about 120. This one's about 130. And just make sure that on that fifth one that it does add up to 540. Let's see, I've got 190 and 250, which gives me 440, so that gives me a 100-degree angle here. And I want you to do the same thing. I want each of us to try this. So here I've got a pentagon, a hexagon, and a triangle. My next step, here's what I want you to try next. Take each of these and draw. Do you remember exterior angles? These are all interior angles because they're in the house. They're inside the shape. At each vertex, I want you to draw an exterior angle. And everybody remembers that linear pairs always add up to 180. So if this angle's 90, this angle's 90. And you can draw it either direction. I don't care if you draw the exterior angle this direction or if you draw it this direction. If this is 100, then this exterior angle would be 80. If this is 130, then this exterior angle is going to be 50, and so on and so forth. So once again, here's what I've done. I've got 3 different shapes, and I know that in my pentagon that all these have to add up to 540. So I've made them all the interior add up to 540, and I drew exterior angles at each vertex. In that hexagon, I knew that they all had to add up to 720, so I made sure the insides added up to, just to give me a generic hexagon. And the same thing with the triangle, they all added up to 180. And I branched off and I drew all these exterior angles. Now what I want to do next, take each of these, in this case I have 5, take each of these 5 exterior angles and let's add them together. Take each of these 6 exterior angles and let's add them together. Take these 3 exterior angles, let's add them together. And let's see what we get. And you do the same thing for yours. Take all your exterior angles, find the sum of them, and let's see what we get. 80. Well, let me pull my calculator back out. I have 80 plus 50 plus 60 plus 80 plus 90. And I got 360. In my second shape, my exterior angles were 60 plus 65 plus 55 and 60 plus 55 and 65. 360. In my triangle, I have 130, 110, and 120. 130 plus 110 plus 120. And I get 360. So no matter what the shape was, that's odd. No matter what the shape is, whether it be a pentagon, a hexagon, a triangle, a nonagon, a dodecagon, a 100agon, the exterior angles of that shape will always add up to 360 degrees. No matter what shape you have, the exterior angles will always sum to 360. And I think there you go, there's the theorem. The sum of the exterior angle measures of a convex polygon, one angle at each vertex, is 360. This is a theorem that you don't have to learn, but it's going to save you a lot of time if you do. You don't have to learn it, but it will save you loads of time. Now let's work a problem. We know that we have a pentagon here, and they drew an exterior angle at each corner. So my equation, 2x minus 5 plus 5x plus 2x plus 6x minus 5 plus 3x plus 10 will have to equal 360 degrees. The exterior angles of any shape will always add up to 360 degrees. So here we go. 2, 5, 2, 6, 3. How many total x's is that?
18.
That's what I got too. 18 x's is equal to, we have a minus 5, a minus 5, and a plus 10. What's minus 5 plus 10? So you're going to add 0 to the other side, or take or subtract if you want to. You can do it either way. You get 360. So x is 20. We plug it back in. We got 70 degrees, 35 degrees, 100 degrees, 40 degrees, and 115. And you could actually find, because they're linear pairs, you could actually find the interior angles as well if you wanted to. So again, reminder, the exterior angles of any shape will always add up to 360. Find the measure of each exterior angle of a regular nonagon. This is tough. Y'all watch how hard this is. Find the measure of each exterior angle of a regular nonagon. Okay, regular means all the angles are going to be the same. If all the angles are the same, are all the exterior angles going to be the same? Does that make sense? If you've got some shape, let's say it's a pentagon. If it's a regular pentagon, that means all the angles, let's see, they add up to 540. That'd be 108 apiece. All the angles would be 108 degrees. What about all the exterior angles be? 72, 72, 72. So if all the interior angles are the same, all the exterior angles are the same. So if you have a regular nonagon, how many sides does it have? 9. It has 9 angles. What are all the exterior angles going to add up to? Exterior. Careful. Exterior. 360. Well, there's 9 of them. Each exterior angle is going to be 40. What's each interior angle going to be then? Isn't that a whole lot easier? If you use the fact, remember that big formula? Before we had to do this. We had to do n minus 2, we had to multiply it by 180, and then we had to divide it by n to find out what each interior angle is. Why not just do this? How much faster is that, folks? If you have all your exterior angles add up to 360, well, we know if we have 9 interior, we have 9 exterior. We take that 360 and divide it by 9, well, that means that each exterior angle is 40, and the relationship between an exterior and an interior angle is they form a linear pair. They're supplementary. So if 40 is the exterior, then 140 is the interior. And you can plug that 9 in and work this out, and you're going to get 140. It only works for regular. Yes, that is very true. In baseball, home plate is a pentagon. The dimensions of a home plate are shown. What is the sum of the measures of the interior angles of home plate? The sum of the measure, and that's an old problem. I don't know why we're going back to that. If it's a pentagon, 5 minus 2, there's 3 triangles. 3 times 180 is 540 degrees. But here's what I want to do. We're done, but I want to go rework a problem. That's the chapter. But I want to go back and I want to rework this. Y'all remember how tough this was? We have 8 sides. We were asked on this problem to find out how many sides, how many angles we have. We had 8. We had to go through all this long process to do it. Folks, let me show you with a theorem I just gave you. It says the measure of each interior angle of a polygon is 135 degrees. I don't know what the polygon is. I don't know how many sides or angles it has. But I know that every interior angle is 135 degrees. You see where I'm going with this? If each interior angle is 135, what's each exterior angle?
45.
Does everybody understand? Because they are supplementary. Well, if every exterior angle is 45, don't they always add up to 360? So can I not just take that 360 and see how many 45s is in it? What do you get? Was that faster?
Yes.
Yes. Do you have to learn that theorem? No, just don't worry about learning that. You don't have to. Unless you want to finish your test twice as fast as somebody else. Okay, make sure, I would go over and learn that. Again, for this reason, what if, didn't we work 2 of those? Yeah, there's another one. Watch this. Find the measure of each interior angle of a polygon that's 144. We can do this one entirely now in our head. If each interior angle is 144, somebody tell me what's the exterior angle going to be? 30, because they're supplementary. Each exterior angle will be 36. Well, all the exterior angles add up to what? 360. So we want to know how many are there then. If each of them are 36 and they all add up to 360, you'll do 360 divided by the 36 and you get 10. 10 sides, 10 angles. Much quicker.